best thing to think about when you think about Hess's law is a puzzle. What will happen is it will give you a formula that it wants the other reactions to create. When you're done, you can have no more and no less. You have to have exactly that formula that they want you to create, and you have to use all the reactions that they give you. So the first thing I'm going to do is I'm going to see that I need two SO2s. So I'm going to go ahead and number my reactions so that I can kind of trace them as I write them down. So I see that I need an SO2. So I'm going to find a reaction, and I see that in reaction 1 that there's an SO2, but it's on the wrong side. So it is a product. I need it as a reactant. So what I'm going to do is I'm going to flip it. So I'm going to write SO2. I'm going to keep up with the states of matter. And whenever you flip a reaction, you have to change the sign. So the delta H, instead of a positive 10.3, will now be a negative 10.3. But I also notice that I need two SO2s, and I don't see another reaction where an SO2 is where I could add them up. And so I need to multiply this entire reaction by 2. So 2, this becomes a 4, 2, and 2. So therefore, I'm going to take and I'm going to multiply the delta H by 2. So then I'm going to go ahead and I'm going to circle everything that I have that this helped me get. So I know I have my two SO2s, but it also helped me out a little bit, and I got two SOCl2s. So I have two parts of the reaction. So you can put a little check, check, check. So now I need to find my P's. I need two P's. So in the third reaction, I can see that I have P, and it's a solid, and I need, so I'm going to kind of circle these because these are just the reaction numbers. And so I need to, I'm going to write that down. It's on the correct side, so I'm going to just write down P. And in this case, I need two of them. And so again, I'm going to multiply my reaction by 2. So if I multiply the 3/2 by 2, it cancels out the 2. And I'm going to multiply that by 2. And I'm going to go over here. It's still, I didn't flip it, so it's still a negative 306.7. But I have two of them, so I have to multiply by 2. And again, that's still in kilojoules. Now I'm going to circle what it got me. So it got me the P, but it also got me some of the Cl's. I need a total of 5 Cl, so P's good. And it got me 3 of the 5 chlorines that I need. So I know I have 3 of them, so I need 2 more. So then the next thing I'm going to kind of look for is the POCl3. So I look and I see that the POCl3 is a product, and I see some POCl3 as a product in reaction number 2. So I'm going to go and I'm going to write that one down. Kind of extend my page and give me a little bit more room to work with. So I'm going to write down the second reaction, and it's in the right place. So I'm just going to write that one down. It's in the right place, and so I know that I'm just going to leave the negative 325.7 a negative. But again, I look and I need 2 of them. And so I'm going to multiply all of these by 2. So if I multiply this by 2, I multiply this by 2, it cancels the 2's, and I multiply this by 2. So I'm going to multiply this by 2, and again, kilojoules. So I'm going to circle what I've got now. So I have 2 POCl3s, so I have 2 POCl3s. And so the last thing I need to look for are some more chlorines. And so I can see that in reaction number 4, which I haven't used yet, has 2 chlorines in it. But I need those 2 chlorines on the reactant side. So I need to flip this reaction. So I'm going to have my 2 chlorines plus 2 waters, my 4 HCl's, plus some oxygen gas. So I flip the reaction, so this fourth reaction, the negative 2O2.6 becomes positive, and I don't need any more, so I think I'm okay. So I'm going to circle. I have 2 chlorines that I needed, so 2 plus 2 plus 3 is 5, so I'm totally done there. And so I don't need to multiply by anything. But then my last step is I have to get rid of everything that's not circled. So I kind of start off, as long as they're on opposite sides, then they'll cancel out. So I need to get rid of the HCl. I have 4 HCl's, and there's 4 HCl's, so that one's gone. So I have 2 waters over here, and I have 2 waters over here. It's just kind of like playing Go Fish. So I have 2 PCl3s as a product. I have 2 as a reactant. And then I have 1 oxygen over here, 1 O2, and 1 O2 over there. So then at my last look, is everything gone that's not circled? And the answer is yes. I love it when that happens. So then all I'm going to do is I'm going to come over here. I'm going to work this out. So I'm going to do 2 times a negative 10.3. I'm going to do 2 times a negative 3.06, 2 times a negative 325.7, and then 202.6. I'm going to add all of these together, and when you do that, you get a negative 1082.6 kilojoules. Because it's negative, I know that this is a exothermic reaction, since delta H is a negative value. That's how you do Hess's law.